Welcome to this lesson on inequalities. In this lesson, I'll be showing you how to do a quadratic inequation and showing you how to solve that on a number line. So the first step in solving our quadratic inequation, when we look, we see that 3x squared minus 7x plus 2, we can actually use our quadratic formula to find the values of x. But we're not going to do that. We're actually going to use the same method that we use to solve trinomials. We're just going to factorize this because this is actually, this quadratic is in particular is really an example of a trinomial, right? If you're not sure how to do trinomials, you can actually see my latest videos on how to factorize trinomial equations, right? The other thing I want to say is that we're going to actually treat this as an equation to start with. So we're just going to treat it as a regular trinomial equation when you're starting. And when you will realize that we're going to have two values of x. So x is going to have two possible values, right? And in that, we're going to now find out in what scenario using the inequation where x is actually greater than or equal to 0. So we're going to start with a first, and then we're going to move on to b. And we're going to also represent this information on the number line. So you're going to see a total breakdown of how to solve quadratic inequations. So as I said, the first thing that we are going to do is that we're going to take our quadratic trinomial expression right there, and we're going to set it equal to 0. So that's the first step. So we're going to set that equal to 0. And then we are actually going to factorize this. And in factorizing this trinomial, you remember that if you remember, we say that a times c. So this 3 here is a and this is c. And we say a times c is going to give us a positive 6. And listing out the factors of 6, we need to find two of these factors that when added together gives us negative 7. And since a negative 7, we have to choose two negative numbers, right, to give us negative 7. Since negative and a negative also gives me a positive when I multiply them. So when you really do it, you're actually going to get a negative 6x minus 1x, or just x, plus 2 equals 0. So in just factorizing this further, we're going to take out our 3x bracket. We're going to be left with x minus 2 bracket, and here we're also going to be left with negative 1 bracket x minus 2. So that's what we're going to have. So in having this, the next step that we're going to actually have is that 3x, we're going to group the 3x together. We're going to group 3x minus 1 in one bracket, and in another bracket I'm going to have x minus 2, and we're going to set that also equal to 0. Now if you remember, your zero property rule is that if two numbers multiply together to give me 0, either that one of them is equal to 0 or both of them is equal to 0. Now with that being said, it simply means then that we could actually rewrite that. We could just rewrite that, and we're going to have them set, both of them being set to 0. So what am I saying here? I'm going to have 3x minus 1 is equal to 0, and I'm also going to have x minus 2 is equal to 0. So we know that if we're going to solve for x, we're going to take this negative 1 is going to go over as a positive, because we need to get rid of the negative 1 and we would add to get rid of it. So these are really basic information, but I'm just still going through so we can all be on the same page. So this is negative 2. We're going to add to remove this negative 2, and it's going to come over here also as positive 2. So we have right here that x equals 0 plus 2 is just going to give me 2. And here I have x equals, we're going to get rid of this 3 by dividing. And in dividing this 3, we also divide it here. So we have x is equal to 1/3. So two values of x is that x is equal to 1/3 and x is equal to 2. So Just erase that here. So we have x is equal to a third, and we also have x is equal to 2. All right, so I'm going to say something that is very important right now. And what I'm about to say is that if you look, we have two possible values of x. Now, when we look at part A of the question is saying we need to find the ranges of values, the values of x, where x is actually greater than or equal to 0. So if we were to plug in a third into this right here, let's just use this to work out our answer. It's the same thing, but this is factorized. And factorization is just a way of simplifying algebraic expressions. So this and this are the same thing. But we're going to use this because this one is easier to work with, right? So this is more simplified. So x right here, this x, if I were to plug this at 1/3 into the here, and if I plug it in here, I'm also going to put it here. So if I put this, if this I say this is a third, this also will be the same one, a third. So when I put them together, I'm actually going to get 0, right? And if I put 2 here, here, and here, you know that 2 minus 2 is going to be 0, and 0 multiplied by whatsoever this is going to equal to is going to also give me 0. So we know that 0, based on the inequation, it says that where x is either greater than or equal to 0. So we know that where x equals to a third is going to give me 0. So we don't have to worry about these numbers. What we need to find out is if x, if I choose a number that is greater than a third, will it be greater than the 0? Or if I choose a number that is less than 2, will it be greater than 0? So we're doing part A. So we haven't reached part B. Don't focus on part B. We're just focusing on part A. So we need to find where x, find the range of values of x where x is greater than, well, we already know when it is equal to, but we're still using it, greater than or equal to 0. So that's the first thing that we're actually trying to achieve right here. Now, in doing this, we can actually look at our number line. So I'm just going to draw my number line to look at this information right here. We are saying that x is if x is 1/3, we're going to put it right here. So if x is a third, it's going to be equal to 0. So there's no question about that. So we're going to put, because this is an equal and a greater than sign, we use a closed circle. And here now, we're going to put a closed circle for 2. So we're going to put it here as well. So we need to find the two possible ranges of values of x, where x is going to be greater than or equal to 0. So we know the equal to 0 will be a third and would be the 2. That is not the case. However, right, we need to know if we need to have our inequalities to know if x is either going to be values that are below 1/3 or values that are greater than and 2. So we need to know this information, right? So how do we do that? Well, simple. We could just look back at this equation right here, this way of what we did right here, right? And remember that we're actually checking if to see if it is greater than or equal to 0. We know about the equal part. So if I were to choose a number between a third and 2, let's say I'm going to choose 1. If x is 1, so let's write that out. If x was to be 1, bracket, we have 1 minus 2. Will it be greater than or equal to 0? We're going to check that. So 3 times 1 is going to give me 3, and 3 minus 1 is going to give me 2. This is going to be 2. And here now, 1 minus 2 is going to give me -1. And is that greater than or equal to 0? 2 multiplied by -1 is going to give me -2. And we can see that -2 is certainly not greater than 0 right there. So we're not, this is definitely going to be false. So this doesn't work. So we can't choose numbers that are greater than a third. But can we choose numbers that are less than a third? And if we can't choose numbers that are greater than a third, it simply means that we can't choose numbers also that is less than 2. Between 1/3 and 2, we can't use any of these numbers in between. If I were to go ahead and try using 3/2, let us try using 3/2. So 3/2 right there and 3/2 right there. If I were to choose these numbers, so in multiplying this, we're going to have 9/2. 9/2, that's what we're going to have there. And having 9/2, right, we're going to have, well, this literally is going to be, in solving fractions, we know that this is 1/1, and we know that we need to have the same denominator. So we're just actually making things faster by doing this now. So we would have 9 minus, this is going to be 2, that's going to be 7/2. And 7/2 multiplied by this now is going to be, this is going to give us, well, right here is going to have 3/2 minus, this is going to be, this is 2/1, so that would be 2 times 2, so we would have 4/2. So we'll look right here, we would have -1, -1/2. So a -1/2 times, say if we were to have 7/2 multiplying -1/2, we're actually going to get a negative answer. The basic thing is that a positive and a negative is going to give me a negative answer. And once this are going to give me a negative answer because it's a -1/2, that any number in the negative is certainly not greater than, it's not greater than or equal to 0. So that's pretty much, we don't even have to work it out. But this is going to give me -7/2, -7/4, right? And it's certainly not equal to 0. It's actually less than 0. So again, we still haven't found this to be true using any numbers between 1/3 and 2. So I'm just going to erase that, and we're going to try numbers now that are actually less than a third. In trying numbers that are less than a third, we would look at -2, -1, and 0. So let us say that we're going to choose -2 for our test. So we're going to write this 3 and x. Say for example, if x was to be -2, like we said, -2 minus 1 in one bracket. So the 3 times -2, that's going to give me -6, and -6 minus 1 is going to give me -7. So we have -7 here. Here now we have x. X right here, and will also be the -2 minus 2. So -2 minus 2 is literally going to give me -4. I will know that a negative and a negative is going to give me a positive, which is actually going to give me positive 28. And when we look now, we're going to test again the information if it is greater than or equal to 0. So is 28 greater than or equal to 0? And the answer is yes, it is greater than 0, right? So therefore, numbers that are less than a third would make this first part of the question be correct. So any ranges of values that are a third and less is going to make f of x greater than or equal to 0. That's the first part. So we would have to have our first part right here. We would have x is, so this right here we would have x is less than or equal to 1/3. We never had any inequality sign right here. We just had an equal sign, but now we are now defining that any number that is less than or equal to a third is actually going to make this first part of the question, f of x is greater than or equal to 0. Right? So here we tested it. Any values that are less than a third or a third is either going to give me 0 is greater than or equal to a third, or it's going to give me a bigger number which is greater than or equal to 0. Right? So that is the first part. Now, when we look here, as I said before, we can't use any number that is in between a third and 2 because we literally just tested that. So it's obvious that we don't even have to put in any number here, but we could use like a number as 4. If we were to choose 4, here and 4 here, 3 times 4 is 12. Plus 1, that's going to give me 11, right? And 11, so 12 minus 1, so 12 minus 1 is going to give me 11. And 4 minus 2 is going to give me 2. So the next thing now is that multiplying them, we're going to get 11 times 2. So 11 times 2 is going to be 22. And we say that 22 is greater than or equal to 0. So we can say that any number that is greater than or equal to 2 is going to let this equation also pass as true, right? So we can say that it is safe to say that x, now in writing my inequalities for x again, we can say that x is greater than or equal to 4. So there we have it. We have two signs for the inequalities where f of x is greater than or equal to 0. We have one where x is less than or equal to a third, and we have another one where x is greater than or equal to 4. So any number that is between here is going to let f of x be less than or equal to 0. So even in doing this, we can see that these numbers right here, let me just highlight them. These numbers would be the range of value of x, where f of x is less than or equal to 0. Because if you solve this, this is actually going to tell you that this literally is the opposite of this. So if this is here and this is there, then it's obvious that in solving this part of the question, we know that we could actually highlight here. We highlight the same 1/3 because we know that it should also be equal to 0. So we highlight there and we also highlight there, and we would put this right there. So these are the ranges of value of x, where f of x is actually less than or equal to 0. So again, thank you very much for tuning into this lesson. I hope this was very informative. I hope you have gotten much out of it. And please let me know in the comments what you think about it. Please remember to like, share, and subscribe to my channel, and stay tuned for more. Thank you.